Hey there YouTubers, I wanted to introduce you my latest project on my Trans Am. This is a 1976 Trans Am, SE, 455, 4-speed, T-tops, you know the works, you've seen them. I was running a couple turbos on that 455, about 750 horsepower, had a pretty serious fuel system going through the Demon blow-through carb, but I decided to change out and go fuel injection. But I enter the 21st century, and ever since then I've had headaches. One of the problems I'm having is the fuel delivery. Before, my system was satisfactory. Going around corners didn't give me any kind of problems. Now, if I'm running less than a quarter tank of gas and I go around a corner, the pickup will get uncovered on occasion, and it'll suck a little bit of air. With my carburetor setup, it wasn't a big deal because I already had gas in the floats, in the bowls. So the carb never really saw that little influx of air. Fuel injection now, and I see my pressure dropping from 50 psi to 30 psi, and that's screwing up my settings on my computer, and I can't have it. So I gotta do something different to make sure I have 100% fuel delivery all the time, even at quarter, eighth tank, borderline empty. I need to make sure that fuel is in the pump. So there's a couple of ways to do that. The manufacturers these days seem to be going to fuel pump modules. These are 4 or 5 inches in diameter, about the height of a tank, 12 inches or so, and they're designed to suck up 90% of the fuel in your tank. And considering these things aren't baffled, it's pretty impressive they do as good of a job as they do. There's some aftermarket options as well out there. Aeromotive has a pretty fancy one that uses a foam baffle that's supposed to keep the fuel from sloshing around and keep the pumps from starving on you. They use their own fuel pump, so it's a good system, but pricey. Tanks Works also has a pretty good system out there. They use kind of a metal bowl to catch return fuel, so that you always have a supply of fuel in that bowl right there where the fuel pump is. Also kind of pricey, but I thought I could do something better, something cheaper. So let's see how we do here. Alright, so this was my tank as it was before. This is the stock 76 tank. I had it sandblasted way back when. It was kind of rusty, and because my car is mini tucked with 335s, I had to cut a couple inches out of each side, and we welded the sides together and sealed it. Just had a simple sump down here with a 12 AN outlet, plenty strong I thought to feed my Aeromotive A1000 pump. You can see it kind of sneaking up underneath the bumper there. Pre-filter, post-filter around the side. I mean, it should be good for 1,000 horsepower, but like I said, if the pickup becomes a little uncovered, then we were having problems. Airplanes use these 12 volt pattern tank covers for their aluminum fuel tanks. And since this is fairly generic in the aviation field, you can see how these line up nicely. I thought this would be a great way to start the fuel pump module that I'm going to build. These plates, unfortunately, are aluminum, so I can't really use them that well on my steel tank. But if you've got an aluminum fuel cell, definitely check out these little aircraft covers. These may come in handy and save you some time when you're constructing your own custom fuel module. So anyway, I use this as a pattern. Hammer and dolly this thing flat. 4-inch hole saw, look at the hole. And then I had to trim around the inside to get rid of the baffle for the vent. Once that was done, I went ahead and cut another hole in the bottom of my tank and made this little 2-inch sump all the way around, welded it in, tried to TIG it, but my TIG welding skills aren't that hot, so I had to go back over with a little bit of sealer and make sure I didn't have any pinholes. Tested it with water, let it bake out here in the hot sun. It's not leaking, it's doing well. So this tank is now ready to go back underneath this car. Alright, so this is what I came up with my fuel pump module. Got two Walbro. These are your basic, what are they, 245, something like that, liters per hour fuel pumps. These are your basic, $50, $60 fuel pump that you find all over the internet. Buy the real Walbros. There's a lot of cheap knockouts out there. Stick with the Walbro. I think you'll be more happy. Okay. And I made this metal plate based on that aircraft aluminum plate that I showed you before. Welded some washers on the top, tapped them for some pipe threads, and put in my AN fittings. Running two -8 lines out and a -10 line return. These -8 lines will have a T, I'll show you that here in a second. Underneath, I just took some stainless pipe, about 11, 12 inches worth of pipe, cut it into 3, welded them together so that I can mount my pumps to it, like that. I don't know why I got separate filters, that kind of pisses me off, but they can't seem the same ones. High pressure fuel injection line, running my wires together out through a little grommet to my pump. Now, one Walbro pump is good for about 500 horsepower. But even a single Walbro running full speed all the time is a little bit heavy-handed on the fuel system. I mean, you only need to return the fuel you don't need, and you don't need 255 liters per hour when you're idling or cruising down the road. So I do have a fix for that. Alright, right there in that corner you can see my Aeromotive fuel pump, what do you call it, module. It does a pulse width modulation, PWM, signal to the fuel pump so that it runs it at half speed at predetermined levels. I have it currently set at about 3,000 RPMs where it goes full speed. 3,000 RPMs is above my cruise speed. I've got 308 gears in this Trans Am, so I cruise at 2,500 RPMs. I might bump that up to 35 or 4 if I start tapping into that on the highway. Again, I don't need 255 liters per hour when I'm just cruising. Like I said, cruising down the road, I might use maybe 100 horsepower at cruise speeds. So certainly nowhere close to the 500 horsepower that the Walbro pump is rated at. So why work it hard? So that Aeromotive pulse width modulation computer is going to send a signal to my main fuel pump here. It's going to run it at half speed, under 3,000 RPMs. If I hit 3,000 RPMs, it's going to bump this thing up to full speed. Now that signal is also going to go to my other pump as well. But instead of grounding this other pump at the chassis, like I'm doing with the first pump, I'm going to be running the ground for the second pump back up to a solenoid in the engine compartment that is hooked up to a throttle position sensor on my throttle body. I'm actually using an old NOS, nitrous oxide systems, full throttle switch for this, so that when I do go 80-90% full throttle, it will kick in pump number 2. Now, if I go full throttle and I'm below 3,000 RPMs, well, both pumps only see half speed. So still no worry of blowing out tons of fuel back into the tank and causing a lot of unnecessary aeration. But once I hit 3,000 RPMs, then both these pumps are going to go full throttle, and yeah, then things get real scary. Hang on. So that's how my fuel system is set up. One other thing that you need to remember is that on the return line, I've got a -10 return line here. You just don't want all this fuel dumping into the tank next to the pickups, because that has a lot of aeration. So I took the original screen for the pickup and just kind of fitted it over a tube that I bent to engage it. So I said, not popping off. Tubes welded to this fitting, that's not coming out. But this will help to disperse the fuel and to keep it from just, thumping right in there and causing a lot of bubbles. So hopefully that will help out a bit too. So this is my fuel tank level cylinder here. I've modified it a little bit. One, I had to cut the tube and spin the level around a little bit to get it out of the way from my module. My module was going to be hitting on it if I didn't. I also went ahead and lengthened the pump float a little bit and adjusted it so it give me a more true reading of full and empty in the tank. When it's, it always seems to be full when you overfill it. That takes forever to hit the full mark on your gas gauge, and then from there it goes faster and faster to zero. So hopefully with this simple little trick here, it'll read full when full and empty when empty. I like that. But anyway, originally this was like some kind of a vent hose that I cut off. I might use this for a vent still. I will need to weld line some kind of anti-rollover valve or something like that later on. But just for kind of putting this thing together, I'm not too worried about it. There we go. Okay, so now the gasket is cocked properly on the hat. I'll slide this in.